Hey mates, so today we'll be continuing our discussion on feedback mechanisms, and before we move to the topic, let us first understand what a variable means. You all know that variable means something that can change, right? You might have noticed that on days where you drink too much water, you have this tendency of going for urination much frequently than the normal days, right? And on those days when you don't drink much water, you don't pee much often. In the second scenario, whenever you move into a cold environment, your body shivers. But whenever you move into a hot environment, your body undergoes sweating. Like, why are all those things? Okay, so I'll explain you the physiology behind this. Before that, all these parameters that underwent some changes. For example, when you drank too much water, you wanted to pee much often. But when you didn't have to pee much often. So there was something related to the water content in our body, or there was water balance. Similarly, in the second scenario, whenever we moved into a cold environment, our body shivered. And whenever we moved into a hot environment, our body underwent sweating. So in the second scenario, there was something that changed. That was the temperature, right? Like such, there are different parameters in our body that can change in response to the external or internal environment. And some few examples about that is that blood pressure or BP. Then comes the blood glucose level, or our hormonal levels, the amount of different hormones in our body. And like such, we have n number of parameters that have the ability to change with respect to the internal or external environment. These parameters that can change are called variables. Okay. And these changes in variables are perceived or are sensed by different sensors in our body, which are also called as receptors. Okay, so if there are different parameters that can undergo change, then there will be surely different sensors which can detect this change, right? So when there is a temperature change, there is a sensor that detects it. So a sensor that detects a temperature change, or it can be named. Temperature means thermo, sensor means receptor. So those are called the thermoreceptors. Then we have those receptors that detect the change in the water balance in our body, or they are the volume receptors. Receptors that detect change in the blood pressure. Okay, those are called the baroreceptors. So like such, we have different receptors for different variables. I think this small concept is clear for you. Now, let me explain the physiology behind those two scenarios I explained earlier. In the second scenario, when we moved out into a cold environment, the temperature receptors or the thermoreceptors on the skin of our body are stimulated. Okay, and these thermoreceptors send signals to the control center of our body. Okay, and which is the control center of our body? Of course, it is the brain. Okay, and the brain tries to process the signal. The brain processes the signal, and then it decides on what to do. Okay, and how does it do that? The brain sends its signals to his friends. Okay, and in this scenario where the temperature is called outside, his friends are one is the muscle, the second one is the blood vessel, and the third one is the sweat gland. Okay, and what are the instructions given to these friends? the brain asks the muscle to contract vigorously. Why? Because when the muscles contract vigorously, more heat is produced in our body, and thus it can help in maintaining the internal temperature of our body. Okay, and the instruction given to the blood vessel is to narrow down and just allow little blood to flow through him. Little blood. Okay, narrowing of blood vessels means constriction of blood vessels. And what is it called? It is called vasoconstriction. Vaso means blood vessel, constriction means to constrict. So the blood vessels are asked to undergo vasoconstriction so that only little amount of blood passes through them. And why? Because when little amount of blood passes through them, the amount of heat lost is minimal. Okay, so in this way also the body tries to preserve the heat or the internal temperature of our body. And what does it ask the sweat gland? It asks the sweat gland to remain closed, because here we don't need sweat to be produced. And what's the action of sweat? It causes evaporative cooling effect, right? So we don't need a cooling effect here when the external environment is too cold itself. Similarly, when we move into a hot environment, what happens? The thermoreceptors are stimulated, signals are sent to the brain processes them and asks his three friends. Here the muscles, the blood vessels and the sweat glands. And what would be those instructions? You can give it a guess, right? Here the brain in this scenario asks the muscle to relax, because we don't need extra heat to be produced when the external environment is too hot. So the brain asks the muscles to relax. It asks the blood vessels to widen. Why widen? Because when the blood vessels widen itself, it allows more amount of blood to pass through the blood vessels, and thus when more blood passes, more heat is lost, and thus providing some cooling to the body. And what does it ask the sweat gland to do? It asks the sweat gland to produce sweat, because as I told earlier, sweat glands release sweat to cause evaporative cooling effect for our body, and thus trying to maintain our internal body temperature. Okay, this is the physiology of what happened in the second scenario. So you yourself can give it a guess for the first scenario. When someone drank more than enough or large amounts of water, the water balance or the volume receptors in our body are stimulated. It sends signal to the brain, and the brain understands the need to maintain the water balance in our body, and so it asks the kidney to flush out extra water from our body, the reason for which they undergo urination much more frequently. But in the other scenario where the person doesn't drink water at all, the body has very much little amount of water, and the brain in this scenario asks the kidney to conserve or preserve the water in the body so that the body doesn't undergo dehydration. Okay, here it also does one thing, that thirst centers in our body are also stimulated so that we feel the need to drink water, and thus we drink water. Okay, now let us modify this flowchart a bit more. We have a change in variable. When we had a cold environment, it was a variable, right? It was a variable. We had the thermoreceptors which were stimulated in that scenario. So we have certain receptors that are stimulated in response to the variable or change in variable. And the receptors sent signals to the control center of our body. In this scenario, it was the brain. Okay. And in brain, there are specified locations where this information is processed. So receptors send information to the brain, and the brain processes the signal, and it then sends signal to his friends, and the friends execute those instructions, and the desired result is achieved. Right. Those informations which are sent to the brain, or these information which are sent to the brain by the receptors, are called the afferent signals. A-F-F-E-R-E-N-T. Afferent signals. Okay. So afferent signals reach the brain processes, and then it decides on what to do. It then sends signal to its friends. Okay. And what are those signals that are sent to the friends called? Or those signals which are sent by the brain. So signals sent by the brain to his friends are called the efferent signals. Efferent signals. The first one was afferent, the second one is efferent. Efferent signals. And these signals are received by his friends. And these friends who execute the orders of the brain, okay, are called the effectors. Effectors. So let us modify the blueprint. We have a change in variable. Our receptors are stimulated in accordance to the change in variable, and these receptors, after being stimulated, send afferent signals to the brain. The brain processes the signal, and it sends signal to his friends. And what are those signals called? The efferent signals. Efferent signals to his friends. And what are those friends called? Effectors. And these effectors perform accordingly, and the desired result is achieved. Okay. So this is the blueprint when our body tries to fix something, or tries to maintain the homeostasis when there is a change in a variable. Now, you can notice one thing. This change in variable, it can either be increase or decrease. Whatever may be the change, our body tries to adjust and compensate to those changes and act accordingly. So this mechanism that is existing with our body is referred to as the counter mechanism, because it counters any changes in our body, right? And since this counter is opposite to the change, if the variable increases, the body tries to decrease. If the variable decreases, the body tries to increase. So the change in variable and the counter mechanisms are opposite in action, and thus mechanism is also called the negative feedback mechanism. So if we have the negative feedback mechanism, then there must be something called the positive feedback mechanism that exists, right? Yes, you are right. There is something called the positive feedback mechanism that exists in our body. But here the positive feedback mechanism has a totally different function. And two examples of or two scenarios where the positive feedback mechanism is in action are: one is the parturition or birthing reflex. Means, in normal circumstances, after the mother protects the baby for 9 months in her body, that is in her womb, baby descends. Consider this to be the uterus. We have a baby. Okay. When it is time to come out, the baby starts to descend. Means it starts to come down. And when it comes down, we have the baby's head, which touches the outlet of the uterus, which is called the cervix. Okay, which is a muscular structure. So when the baby descends, or when the baby comes down and its head starts to touch on the cervix, the uterus starts to contract so that it can push the baby further down. So the uterus starts to contract slowly, and it is because of these contractions the mother screams in pain, because these contractions are too painful. So the uterus starts to contract, the baby is then pushed down into the cervix, and the head of the baby stretches the cervix. And what happens here? When the head of the baby stretches the cervical muscles, stretch receptors in the cervix are stimulated, which sends signal to a specified area of the brain called the hypothalamus. Okay, hypothalamus. And the hypothalamus in turn asks the pituitary gland to release certain hormones. And what are those hormones? One is the oxytocin. Oxytocin acts on the uterine muscles or the muscles of the uterus and causes further contraction. Okay, so when there is further contraction, the baby is pushed into the cervix more. And what in turn happens? The cervical muscles are again stretched, and the stretch muscles or the stretch receptors are stimulated again, and it then again sends signal to the brain, and the same action continues until the baby is fully expelled out from the mother's body. Okay, this is the parturition reflex. Okay, so in summary, when it is time for the baby to come out, it starts to descend and the uterus starts to contract. When the uterine contracts, it pushes the baby further down into the cervix, which is a muscular structure, is stretched by the head of the baby. And when it is stretched, it stimulates the stretch receptors in the cervix, which in turn signals the hypothalamus. The hypothalamus then instructs the pituitary gland to release oxytocin. Oxytocin acts on the uterine muscles to cause further contractions, and these contractions again pushes the baby further down into the cervix. The stretch receptors are stimulated again, and this circuit or this cascade continues till the baby is pushed or expelled out from the mother's body. The second one is the milk ejection reflex. Milk ejection reflex. Here we have the mother's breast. We have the nipple here. When the baby starts sucking the mother's nipple, certain mechanoreceptors in the mother's nipple are stimulated. Mechanoreceptors are stimulated, and these signals are sent to the brain. In this case also it is the hypothalamus. The hypothalamus then asks the pituitary gland to release not one but two hormones. One is oxytocin. The second one is prolactin. Okay, and what are the functions of these hormones? Prolactin increases the milk production in the mother's milk glands, which are located in the breast. Prolactin causes more milk production in these milk glands, and is only production needed. The milk must be ejected out so that the baby can drink it, right? So that function is served by oxytocin. After the milk is produced, oxytocin contracts the milk glands and causes milk ejection and straight into the baby's mouth. Okay, this continues as long as the baby keeps on sucking on the mother's nipple. Okay, and when the baby is full, it stops sucking, and thus the mechanoreceptors on mother's nipple are not stimulated. No signal goes to the hypothalamus, and thus the hypothalamus does not act on the pituitary, and no hormones are released. So as long as the stimulus is present, the cycle keeps on continuing and it keeps on amplifying, right? Thus the positive feedback mechanism is also referred to as the amplifier response. So that's all about homeostasis and feedback mechanisms. And by the way, apologies for the syncing issues in the video. We'll make up for it in the next video for sure. And hope you have enjoyed the video and it made all sense. Till then, see you in the next video. Bye.